Cassandra being a great mythological character is fraught with tons of baggage. Cassandra was the oracle that no one believed. It's like, good mascot.
But she was right. But she was right.
But she was right. Yeah, that's the thing. Actually, there was kind of a tongue-in-cheek. There's a little backstory. There's a tongue-in-cheek joke by Avinash, who was one of the original. He was a founder or original builders of Cassandra. That it's like she also foretold the doom of the Oracle. It's a database joke. All right, it's a database dad joke. It's really bad.
And you were an Oracle guy, so
Whoa, man. Yeah, we're just gonna wrap that right up. So I think your question. So, dad jokes aside, your question is about what is it about Cassandra that's going to make it a Kubernetes database?
Yeah, what are the things that are necessary to get Cassandra ready to be comfortable to be running functionally and openly on Kubernetes?
I'm glad you asked, because we've already started that process by modularizing. So we use in the Cassandra project, we use these things called CEPs, Cassandra Enhancement Process. And they're just how we propose new large scale features instead of just dropping a ton of code or opening a Jira and saying, I got a great idea and here's my code. We have more structure around how do we advance the project, like big things that are changing. There are several CEPs, and there will be more coming around building more modularity into the system. As I mentioned, right now is when you deploy Cassandra, you can choose anything you want as long as it's local file system. And that's great. Did you want a local file system? Great, that's the choice. And the storage system is what is built into Cassandra as well. Now, Instagram has kind of taught us a different way, which is thanks not just because they teach us how to do social media, but Instagram has integrated RocksDB with Cassandra in this thing they call Rocksandra. That opened up a lot of doors when people are thinking about how that works. So modularity and storage is one of them. Being able to provide a variety of database or a storage choices below the line. So if you think about, like, again, network, compute, storage. Network is the API layer. Like, how are we going to do this? We've started an open source project called Stargate, which is out there, which is basically abstracting the API layer above the compute side of Cassandra. So Stargate allows for things like REST, GraphQL, gRPC, document, whatever API you want to use to access your Cassandra compute layer. And then in Cassandra project, we're being able to do pluggable storage. So instead of just using what we call the 8099 engine, which is the only engine you can use, the storage engine you can use in Cassandra, being able to bring your own. So maybe it's something like a RocksDB or something like that. And there are a lot of choices to use. So all of these things, the punchline is that we will be able to use those and compose them in different ways in a system like Kubernetes.
Very, very good. Jeffrey, anything to add to that? Any thoughts, reflections?
Well, I think that there's one thing well, it depends a little bit. I always say that it depends. It's a little bit of annoying, but it is actually really true. But one of the things that is not obviously clear is just like, what is the behavior of the system when resource constraints come into play? And this ties back into Litmus, as you mentioned before, because when you have a new Kubernetes cluster, everything is hunky-dory. But when things start to shape up like at random and badly, it's like, which application gets to suffer first, and how do I control what gets suffered or sacrificed first? And I think that's something that needs to be looked out for. And I think there was this. I'm not sure if it's still the case, but you saw a lot of Kubernetes clusters that had a specific function, right? It's like, this is my Kubernetes cluster that runs Cassandra, and this is my Kubernetes cluster that runs whatever, right? And I think that keeping a a system that constantly is able to monitor and advise you to a certain extent about the state of the system and what its breathing room is in terms of network saturation, disk saturation, and CPU saturation and whatnot. Because right now it's only during scheduling, and if you have a system that needs to, I don't know, rebalance or do some checksumming or Merkle trees. Cassandra uses Merkle trees, for example. Wow, that's really cool, right? Or at least they used to. I'm not sure if they still do. That's really, really cool, but it's not cheap, right? I mean,
Every day.
you have to do some CPU work, which is fine, but how do you size it out? How do you get the bandwidth correct? And I think, yeah, again, the right tooling is important, and validation through Litmus, but it's not all that obvious when you start out deploying your application, like what it will grow into. And that is very difficult to assess. And even so with distributed databases as well, because as you lay out the data in certain table formats, you anticipate the data to be queried in a certain way, but well, it turns out that 2 years down the line, you were wrong, right? It's very difficult. So yeah, I think it's a good thing because that gives us job security, right? I mean, after all, software engineers should really just make sure that they have a job by adding random bugs and making no code comments, right? It's like that's how you do it. But yeah, I think I'm diverging a bit, but yeah, because the question was is like, what is it that you need to have in order to run Cassandra on Kubernetes, right? And I think that obviously storage composability, Cassandra itself, obviously, but then also it's like, what do you do when the kubelet decides to kill your pod or you know you screwed up your YAML, for example? How do you validate that? And I think that's very, very important to consider as well.
I'll help you with this one, Jeffrey. Is how about some consistent storage? You know, and storage that's better suited for Kubernetes. You know, I think that is one of the things that Evan and I first started talking about with regards to